Hi everyone, my name is Maggie, and in this video we're going to be talking about atomic orbital R functions. So in the last video you went over Y functions, which you get by traveling in a circle around the orbital. With R functions, we're going to travel in a straight line away from the nucleus. Okay, so let's see what that would look like with this orbital. So this orbital has one angular node down the middle and one radial node. And because of that, it is a 3p orbital. So in this video, I'm going to designate that all the areas in yellow are positive and all the areas in gray are negative, but you could have done it the other way. So like I said before, we're going to travel in a straight line away from the nucleus along this line. And you'll see that it will correspond nicely to our R graph. So on the horizontal axis, we have little r, which is the radius, or the distance away from the nucleus. And on the vertical axis, we have capital R, which is the value of the R function. Okay, so let's look at a couple points. So we have purple, dark blue, light blue, and green. Okay, so starting with purple, we could see that the purple point has a radius of 0 because it's at the nucleus. And it also has a capital R value of 0 because we are at a node, which means the electron is not located there. So I'm going to add that to our function. Next we have dark blue, which is located here. And dark blue has a positive value because it is in a yellow lobe. So I'm going to add that here. Next we have light blue, and light blue is again on a node, so it's going to have a capital R value of 0. So add that right here. And finally we have green, which will have a negative value since it's in a gray lobe. Okay, so to complete our sketch, I'm going to connect all these points together, just like that. So there we go. There's the sketch of our R function for a 3p orbital. Okay, so some things that you should notice is one, whenever we're at a node, our capital R value is always going to equal 0 because the electron is not there. Another thing to notice is that our bumps are going to alternate positive and negative. And that makes sense because as we move away from the nucleus, our bumps are going to alternate positive, negative, because it's a wave. All right, and third, you should notice that our bumps are going to get smaller as we move away from the nucleus. And that's because the electron is negatively charged and the nucleus is positively charged. So it's the most stable when it's right next to the nucleus. All right, so this was just our sketch of the R function. I'm going to show you what the actual R function will look like. So here we have it. It has the same general shape as ours. Starts at 0, gets positive, goes back through 0, and then ends in the negative region. Okay, and you'll also notice that after we start at 0, we only cross the horizontal axis one time, which corresponds to our one radial node. Okay, so let's try another example with a different orbital. All right, so we are going to do this orbital next. So this orbital just has one angular node going down the middle, and therefore it is a 2p orbital. Okay, again, this is negative and this is positive, and we are going to move along this line. All right, so we're going to start at 0 because we're at the nucleus at a node. And then as we move away from the nucleus, it's going to get more and more positive until we're in the middle of this lobe. And then after that, it's going to stay positive but decrease in value. All right, so this is what it's going to look like. Again, you should see it starts at the origin, gets more and more positive, and then decreases in value, but it stays positive. And you'll notice that we never cross the horizontal axis after starting at 0, And that's because there are no radial nodes in the 2p orbital. All right, so we're going to look at one more orbital that's a little bit unique, and that is this one. Okay, so this orbital has no angular nodes. It just has one radial node right here, and therefore it is a 2s orbital. Okay, so I'm going to say blue is positive and gray is negative, and we are going to move along this line. Okay, so let's look at a couple points. We have purple and blue and green. Okay, so starting with purple, so purple point still has a radius of 0 because we're at the nucleus. But if you'll notice, we're not actually at a node this time because there are no angular nodes going through the middle. The purple point is actually as far away from a node that you can be in the middle. So the purple point is going to have a very large capital R value. So I'm going to put it up there. Okay, moving on to the dark blue point. The dark blue point is at a node, so it's going to have a capital R value of 0. Then our green point is going to be negative. So our R function is going to look something like this. And you'll notice this looks different than the R functions we've looked at before because it does not start at the origin. And this is actually true of all s orbitals. So s orbitals don't start at origin. And this is due to the fact that there's no angular node going through the middle of the orbital like there are in the other ones. Okay, so you'll see that in the actual one as well. The 2s1 starts with a high capital R value, goes through 0, and then ends in the negative region. Okay, I hope this video was helpful. Thanks for watching.